Hi and Assalamualaikum everyone. Now we are going to continue to discuss the non-equilibrium part of MOS capacitor. This is under chapter 7, MOSFET. We have discussed that the gate structure of a MOSFET resembles a capacitor. In fact, it can be considered as two capacitors considering the insulative oxide layer and also the depletion region of the substrate. We have also discussed on the MOS capacitor at equilibrium, meaning that under no applied bias. Under equilibrium, at the SiO2-Si interface, band bending happens that create the built-in voltage and depletion region. I have also showed that the interface between the SiO2 and Si, the Fermi level intersect with the intrinsic Fermi level, Ei, making the Fermi level Ef higher than Ei. This creates an effectively n-type region in a p-type substrate. The objective of our lesson today is to discuss on the three behaviors of the MOS capacitor under applied bias at the gate. The three behaviors are accumulation, depletion, and inversion. We start with accumulation. Accumulation happens when negative gate voltage is applied to N+ gate of MOSFET. Applying negative voltage means higher potential energy for electrons at the gate side. This makes the gate side moves up. The negative charge on the gate attracts hole from the substrate to the outside semiconductor interface. So positive charges accumulate at the surface of p-silicon substrate. This results in upward bending at the surface, making EF close to EV. Next, we move to the depletion. When a positive voltage is applied to the gate, depletion region is created. The holes at the interface are repelled and pushed back into the bulk, leaving a depleted layer. Thus, depletion region is created. There are only acceptor ions exist in this region. As time increases, electrons will be thermally excited into the conduction band, where they will be trapped in the potential energy well at the interface. Further increasing positive Vg, when Vg crosses threshold voltage, the increase in depletion region width stops. There exists a negatively charged inversion layer at the outside semiconductor interface in addition to the depletion layer. This inversion layer is due to the minority carriers that are attracted to the interface by the positive gate voltage. Excess electrons are induced at the surface. The surface of the p-type semiconductor then has been inverted. That means effectively becomes a n-type. At this time, there are more electrons than holes. Thus, the excess carriers are electrons. The further downward bending results in Ei crossing the Ef. The electron concentration depends exponentially on Ef minus Ei, meaning that the larger value of Ef minus Ei means higher electron concentration. At a sufficient voltage, the surface electron concentration is equal to the substrate concentration, which is the criterion for inversion. This minimum voltage that is sufficient to form a channel is called threshold voltage, Vt. The channel is now ready for conduction, of which the flow of the carriers in the channel is controlled by Vds. From the previous discussions, we have mentioned that the gate structure can be translated into two capacitors. One is based on the oxide layer and the other one is based on the depletion region of the substrate. Thus, we should consider two capacitance in series, COX for oxide capacitance and CS for semiconductor depletion region capacitance. In accumulation, the MOS capacitor behaves like a parallel plate capacitor with the SiO2 as the dielectric, and thus total capacitance C is equal to COX. Under depletion, it can be represented by a series combination of oxide capacitance COX and semiconductor depletion layer capacitance CS. In inversion, the capacitance depends on the frequency. At low frequency, C is essentially equal to COX, and at high frequency, capacitance is a series of COX and CS. To summarize, there are three behaviors of MOS capacitor. Accumulation happens when we apply negative gate voltage, Vg. Depletion is the result of positive gate voltage. And further increasing the positive gate voltage will result in inversion. At inversion, conductive channel is created. The minimum gate voltage to form a channel is known as the threshold voltage, Vt. And lastly, the calculation for capacitance should consider two capacitance, which are COX, the oxide capacitance, and CS, the semiconductor depletion layer capacitance.